are Group 4. In our program is a game called MazeBall. And I am Elvin Cruz.
I'm Khayam K.
And I'm Earle Kit SANCHEZ. Game development had progressed within the years. Countless of fields of or genre of the game can't be summarized into a single category. A game is somehow described by the movement, aggregation, and interaction of hundreds of billions of pixels governed by a logic which simulates a phenomenon or a special behavior.
The assembly programming language is a versatile tool and almost arguably the most powerful one. But assembly language is also one of the most difficult programming languages without a doubt. Our game is based on an old arcade game with the same title and same gameplay. But our game differs from the base online games that are black as arrow that guides all the ball and has trap blocks in which represented by the red block.
The game was made to run inside the DOS emulator. BIOS interrupts were used for most of the inputs into the game, such as the keyboard and mouse inputs. Different interrupts were used for visual aspects of the game. The MS-DOS routine interrupt, on the other hand, was used mainly for file handling.
The significance of our program is to demonstrate how a certain program or game specifically accommodate keyboard and mouse interactions and run it in a platform, specifically the disk operating system or the DOS, in which this type of demonstration or other learning material sources about assembly programming are inadequate as the use of assembly is getting more specific for hardware purposes. This study can be of help for someone that is just starting in assembly programming. This study can also provide a reference of most of the mechanics and capabilities of the assembly language in simple game development.
MazeBall is a logic game where you must guide the green ball to reach the target blue block without falling into red traps or hitting the border as fast as possible. This type of game requires focus and sense of direction. The proposed game should be developed by applying the acquired knowledge of assembly programming, used in the laboratory drills, and all concepts imparted in the class lecture.
The general objectives of this study are to be able to apply all the concepts learned in computer system organization with assembly language, to develop a game that demonstrates the concept of assembly language, and to successfully create and finish a proposed game without any errors and that would be enjoyable to play with a player.
Now, let's start. The game has a timer that only stops when you finish the game. The blocks have arrows that corresponds to what will be the direction of the ball once the ball hit it. The arrow can be changed by left-clicking it. Once the user is really sure about the placement of the arrows, the user must press W for up, A for left, S for down, and D for right. Now, for this level 1, we shall press D. Voila! We're now in level 2. So answering level 2, I should put the arrow here, going up, going to the left, go here, here. You have to keep in mind that the green ball shall not touch the red boxes and the blue border. Going up, left, going down, and then going left, going down, and then going right. Okay, let's press A. Now, we're in level 3. So, that's the demo, guys. You shall be able to know how the game goes by now.
Scopes and delimitations. Keyboard and mouse operations are restricted to just apply input into the game. The graphics mode is restricted to display 256 RGB colors with a limit of 320 by 200 pixels for the specified resolution. The techniques of assembly language that is used for this study is limited only to keyboard and mouse input and display applications. This is how our game works. Basically, if you run a program, you will be asked if you want to start the game or exit the game. When you click exit game, the program will terminate. On the other hand, if you click start game, it will begin on level 1 right after. Here, you will need to use both mouse and keyboard. For mouse, it will be used in changing the block direction. For keyboard, it will be used in making the ball go in a certain direction. That's that. And the tricky part of our program is this. When the ball bumps into a block, the program will be conditioning the ball based on the color of the block it bumped. If it's red, it will restart the level. If it's brown, then the ball will move according to the direction of the brown block. And if it's blue, we go to the next level until we finish level 5. All the declarations used in our programs. First, these lines were used for the main menu. Here we can see the title of the game, the start key, main menu, and exit buttons. Next, these lines will be the one you will see per level. For example, if you are at level 1, you will see the title level 1 and the timer. And then these lines were declared for the black lines for clearing the specific pixels in the circle. And then these are for the circle. Next is the border. This will be the Y and X coordinate for outer border, X and Y coordinate for inner border. These lines are for the brown block inside the game. And then these lines will tell you if you lose the game or win the game. The single line will dictate the level you are in. This will increment as you progress to another level. These lines are for the arrows, and you can check what arrow is used, forgetting the coordinates for the mouse input, parameter per arrow of blocks, checking the parameter of the arrow, forgetting the current coordinates of the ball, or the timer, and function 0013 or 320x200, 256 color graphics, and here is the mouse initialization.
So now I will discuss the rest of the source code. Since these codes were discussed by my team group mate, I will start discussing the create BG function. So this code right here is a BG changer. So basically it just clears the screen. So this code is used to create a border. So these numbers right here is the coordinates of our border. So it calls the function create outer border, which we'll also discuss later on. And next is this code. So this code is used to output our destination blocks that we use as the display or design for our title page. So since we have 15 blocks on our title page, we also repeat this code 15 times and change its coordinates so that it will be spread out. So there. So next is it calls the call for menu. So that's the end of the create BG. So for menu function, I will now discuss the for menu function. So in the title page, we have two boxes: the start game box and the exit game box. So this code is used to create that box, which will discuss the function of box main menu. So it also has its coordinates so that it will be different. And the next codes are these codes will only output the texts. So this code will output the title, which is the MazeBall, and this code will output the start game, and lastly this code will output the exit game. So that's the end of the for menu function. So next I will discuss the for in-game text. So basically what the name states, the for in-game text. So when you click the start game button, this will output all the in-game texts. So this code right here will output the timer text, the return menu text, and the main level text. So our game has 5 levels. So since we are using the same logic for each level, I will only discuss the for level 1 function. So the only thing different from each level is that the position of the boxes and the number of boxes we created. For that, the difficulty will be harder as we progress the level. So on this part, you put all the blocks that you want to see, and on the level 1, except for the outer and inner border, are fixed. So this code right here identifies what level are you on, and it clears all the parameters, it outputs all the in-game text, and this code right here will output the level 1 text since you're on level 1. So it will also create its own border and its own coordinates, since per level it has different blocks. So per level it also has different borders. So this code right here is the coordinates of our ball, and all the coordinates should be divisible by 5. So it should be easier for us. The block X is X coordinate of the blocks, and block Y is the Y coordinates of the blocks. So next is that this code right here used to create the direction blocks. So we have 6 direction blocks for level 1. So we repeated this code 6 times. So, and differs only the coordinates and its direction. So there. And this code right here is for the destination block. So what is a destination block? So destination block is like your goal. So the ball should bump into the destination block in order for you to finish that level. So another direction block, and we also have a trap block. We have 3 trap blocks for level 1. So what is a trap block? So trap block is a block that when the ball bump into the trap block, it will be game over. So if it is game over, it will just only restart the level. So, and then another is another direction block. So that's the logic of our game. So it will only be same until level 5. As you can see, only differs that the number of trap blocks, the number of direction blocks, the positioning of the circles, the positioning of the blocks. So next is the create green circle function. So this code right here creates the circle. So CX for column and DX for row. So we have 11 loops. So there. So these codes right here, it has many loops because as the green circle moves, it also like leaves a mark. So when the green circle moves, it will only be green circle on its path. So next, so we created a create block pixel top. So when the circle moved, so this, it will erase the path of the circle. So we have a create block pixel for top and for bottom. So we also have for the left side and the right side, but same logic as well. Next, I will discuss the create outer border function. So the outer border is color blue. So this function will only create a rectangle. So we also created a create inner border, so that, which is colored black, so that we will put it inside the color blue rectangle, so it will only make like a border. So next, the ball movements. So we compare it to if it pressed A or the left arrow key, the ball will move left. If D or right arrow key is pressed, so the ball will move right. And if W and up arrow key is pressed, so the ball will move up. And S and down arrow key, the ball will move down. So here we have same codes for each movement. So move left, move right, move down, and move up. So this code right here is the collision detection. So, and this code right here compares if left circle hits a block pixel. So we will then again call the create block pixel right side. So it create block pixels to the position of the previous circle. So in the next lines, we have similar logic, but because it's move left, move right, move up, and move down. So next is creep press. So there, and main game. So afterwards, we'll call create clear screen and call create BG. So after each level, it will clear the screen and create the background, and then move on to the next level. So next is the create block. So this block is for the direction block. So it's colored brown there. The X is for column and the X is for row. So the get block inside is that, so that we will get the coordinates of the block. So same syntax here in the destination block. So the color of the destination block is intense blue. So X for column, the X is for row. So get dest block, so same as the and then create trap block. The color for trap block is color red. So same logic also as the destination block and the block. So delay timer. So this code right here is delay for moving the circle or the ball. So this code will slow down the move of our ball. And the next function is the delay time how to. So it is also delay for moving the circle or the ball. So next, delay game. So this code will delay for moving the game until the end. So and then the next function is the create arrow go right. So as we click the destination blocks, it will change its direction as you click it. So we have 4 functions like create arrow go right, left, down, and go up. So it will call the create blocks because this function is displayed in the middle of the destination block. So this code right here is the arrowheads on the destination block. So and this is to create the right arrow leg, the right arrow edge 1 and 2, so that it will create a arrow. So same code for create arrow go left, arrow go up, and then arrow go down. So next is the checking for arrow right. So we have a detector of parameters. So if our parameter arrow is equal to 1, it will go to down, and if we compare our parameter arrow, it will jump if equal to left. If we compare this line, it will jump equal to move arrow up. So these are the codes for it. So if the parameter is going down and the ball bumped into block which has this move arrow down, it will go down, and if to the left, it will go left and then go up. So same logic here for arrow left, for arrow up, and checking for arrow down. So I will not thoroughly discuss it since it has same logic. And next is the keyboard mouse checker. So here's the keyboard mouse checker. So it call create green circle. So it will also call the timer and the check mouse. So this line divides the CX by 2, and this line checks if the left is clicked, and then we have here it hides the mouse pointer as we click. As the ball moves, the mouse pointer is hidden. So next, mouse input for blocks. So here's the checker for mouse click. So this is basically the mouse input for blocks when you click the direction blocks. So arrow down, left, up, right. So we also have a code for checkbox for move arrow. So it only calls the call checker for mouse click, and it checks the direction. So here, and then this code right here compares if top circle hits the block circle, and it creates block pixels to the position of the previous circle. So same logic for the different directions. So this one's down, up. It also compares to if top circle hits the block pixel and creates block pixels to the position of the previous circle. And left, same. Right, same code. So next is the detect hit. So as I explained earlier, if the ball bumped or collided with the border, with the trap block, it will be game over. So the game will restart. So we compare here we compared it with the 01H, which is the color of the border. So game over. So we also compared it to 04H, which is red, the color of the trap block. And we also compared it to 09H, which is the color of the destination block. So here we have same code for game trap over and game over. So if the ball hits trap, it is game over, and if the ball hits the blue border, it is also game over. So here it stated that if it's game over, we just repeat the game level. So here's check level. Increment if you pass the destination block. Repeat game level. So since it has been identified what level you are here in game, what level, so we will just compare if it's 1, 2, 3, or 4, 5, and if it is equal, we'll jump to its level. So this is the win. It will output that you win, and it will delay game so that it will not be fast, and it will create clear screen and delay game so that the movements of our program is not that fast, and it will again create clear screen and will exit there. So here are the codes for when your level is identified, so will delay game. So if you're level 1, you will go to the for level 1 function. If you're level 2, for level 2, for level 3, for level 3 functions, and so on. So next function is the checker for mouse click. So we have a checker input. This will compare if 1, 2, 3, or 4 or 5. So it will also be check the level there. So if first level, it compares the check block 2, and we have check block until number 97. So I will not thoroughly discuss this because it has the same logic. So for the next function, we have the create clear screen. So this will clear the screen as what the function name states. So this is the box main menu function. As I told you earlier, it is the box in the title game. So it is color green with the shadow. It's light green with the shadow of green here. So this is the shadow, and this is its main color. So the boxes, so that we have block box in our title page. So, and the mouse main menu. So this is how we created the mouse pointer. So the CX needs to be divided by 2 and check if left is pressed. So the timer. So the timer is used for each and every level. So the timer is just seconds. The typical timer. So the timers will start counting as you press the start game and until you finish until level 5. And lastly, the clearing parameter. So it will just clear all the parameters we used, and that's the end of our source code. So we used push A and pop A because the push A instruction pushes all the general purpose registers onto the stack in the following order: AX, CX, TX, BX, SP, BP, SI, DI. So the value of SP pushed is the value before the instruction is executed. So it is useful for saving state before an operation that could potentially change this register. And the pop A is this instruction that pops all the general purpose registers of the stack in the reverse order of push A. So that is the DI, SI, BP, SP, BX, DX, CX, AX. So it is used to restore state after a call to push A. Our team believes that life is not a maze, because life is amazing. Thank you for listening. Play our game and get exclusive discounts on our future games.